Hello, welcome to everyone. So I am going to start a series of lectures on calculus. So this series is going to be a many number lectures. So that I will indirectly cover calculus part. If you have any doubts in this regard, you can reach out to me on my Instagram channel. So which is mentioned in the description. So in calculus, to start with the calculus, I will teach some concept called intervals. First of all, I will define what is an interval and we'll talk about the function modulus function. Okay, for today, I will teach you interval concept, modulus of x concept. Yeah. So if you see any number which are forming part of natural numbers can be written as 1, 2, 3 and so on. Similarly, integers are defined as negative numbers 2, minus 1, 0 and so on, 1, 2, 3 and so on. Rational numbers are defined as the numbers which can be written in the decimal form p by q, where q not equal to 0. These are defined as rational numbers. Few examples are 1.5, 0.04 and so on. Now, irrational numbers are the numbers which cannot be represented in the form of decimal fractions, or which cannot be represented in the form of p by q forms. So example is root 2 pi and so on, root 3, fifth root of 4 and so on. If we see, any recurring decimal can be converted in the form of rational number. Okay, rational numbers are ones. There is no repetitive pattern that is going to be followed in the decimal forms. Irrational numbers cannot be written in this form also. If you are writing in this form, definitely you are going to have rational numbers. So since we have come across this, today I will solve a small problem to convert a decimal fraction into to convert this recurring decimal into a decimal fraction. I will take this problem. Okay, whenever you find this kind of problems, assume x is equal to 0.234. Okay, now since there are two decimal parts are recurring, we have to take 100 as our multiplying factor. Now if I take 100x, I am going to have 2.34. If I multiply this by 100, I am going to get 23.434 and so on. Next I am going to have 0.234 and so on. So the rationale behind multiplying the with 100 when we are having two decimals is that after a fixed part we are going to have same recurring part in both of the numbers. Now when I subtract equation 1 from 2, what I am going to have is 99x equal to 23.4 minus 2 is 2 and the rest all is going to be 0. So x can be written as 232 divided by 990. So in this way we can convert every recurring decimal number with a fixed period into a decimal fraction. So these kind of problems you will see in class 10th, I think so. Okay, because we have come across this, I have covered this part. Now let us move further. So our topic of discussion is intervals. So what is an interval? We say a comma b is an interval where x belongs to a comma b and a comma b is an interval. That implies x is lesser than the left boundary. X is greater than the left boundary and less than the upper boundary, or we can call it as upper limit. Here in this interval, a is lower limit, b is upper limit. Now we are having x belongs to a comma b implies x is lesser than the upper limit and x is greater than the lower limit. So an interval is defined like this. Okay. Now when we have a comma b and the braces are normal braces, we call this open on both sides. Okay, but if we have square brackets, then we call it as closed on both sides. The word closed means, when we say closed means this is also included. When we say the interval is closed means this is also included. Even these values are included. Say when x belongs to a comma b, closed a comma b means x can be greater than and equals to a and less than and equals to b. Okay, this is the condition. So just a reminder not to get confused. Whenever we are having square brackets, we call this interval as closed interval, and the value and the limit or either upper limit or lower limit is also included in the value of x. Now, so let us write this interval. So this interval is open on left and closed on the right side. Okay. Now how we'll write this equation? In equation, x is greater than a, less than b. Since we are having closed in the right side upper limit, b is also included in the value of x. So this is the condition for this interval. Okay, I hope the concept of interval is clear. So I will take one more example like this. So you are going to tell me how I should write this. X is greater than or equal to a, x is less than b. So you should never forget what is a open interval, what is a closed interval, and what values x is going to take when we define either closed or open intervals. Okay. So I hope the interval concept is clear. If you have any doubts, you can reach out to me on my Instagram. I am always there to help you. Any doubt in mathematics, you can always ping me. This is my Insta ID. Okay. So now I have teach you the concept of intervals. Now we will come to modulus or absolute value of a real number. Absolute value of a real number is a function. It is defined as positive value of the given real number. If we say I have 5 the absolute value is 5 itself. If I say 5.3, absolute value is 5.3. If I say minus 5.3, then the absolute value is going to be its part 5.3 only. So the absolute value can be defined modulus x is equal to x if x is greater than 0, and modulus x is equal to minus x if x is less than 0, and it is equal to 0 when x is 0, implies x is 0. Okay, so in starting classes, many people may get confused. Sir, modulus x, it is always a positive number. How you have written modulus x as minus x? So this question many of you might have got. I mean, at least in our lower classes, we'll get. Even I too had the doubt. So what happens is, if I say modulus of minus 5, that is equal to, if I just write mod x value, I am going to get minus 5. To counteract this minus 5, we are going to have, if you see here, we have extra minus. This minus counteracts with the negative minus already present with the number, and thus minus of minus we are going to have 5. So that is why we have modulus x equal to minus x when x is less than 0. That means if you have a negative number, its modulus is minus of minus that number. Say minus, I have minus 7.3, its modulus is minus of minus 7.3. See, this is x, okay, this whole thing is x, so we'll have it as 7.3. So now you should always, okay, remember, when modulus x is equal to, when x is negative number, if x is less than 0, the inside part is less than 0, it means it is already having a minus sign, then modulus x is equal to minus x. Okay, this you should remember. Okay, now I am just writing the modulus function again. If you can take down it as notes if you want. Okay, modulus function x is equal to x if x greater than 0, minus x if x less than 0, 0 if x equal to 0. In this way our modulus function is defined. Please write it down as notes. Note down this points. Okay, I hope you all might have noted integrals also. Okay, I mean not integrals, intervals also. So I will just write it down for intervals. If x belongs to a comma b, so wantedly I have taken one is closed, one is open. Okay, this implies x is greater than or equal to a and less than strictly less than b. Okay, so this is strictly less than, this is less than or equal to. We can also write this as x is greater than or equal to a and strictly less than b. Okay, you can take this also in your notes, so that if you get any confusion at a future point of time, you can note it down. I will write if x belongs to closed a comma b, closed implies x is greater than or equal to a and less than or equal to b. If x belongs to open on both sides, then x strictly less than b, strictly greater than a. So here a is called lower limit, b is called upper limit. So note on this. So I'm going to pause for 1 second and note these points. Absolute value, note this very well. Okay, then we'll go to further sessions. Okay.